Good morning to all, and welcome to the official opening of the first study group with industry, the 125th European Study Group with Industry. Brief addresses will be firstly given by the Rector of the Cyprus University of Technology, Professor Andreas Anagiotos, Mr. Karagiorgis, Head of the EU Affairs and Head of Entrepreneurship, Internal Market and Innovation Sector from the Ministry of Energy, Commerce, Industry and Tourism, and Mr. Kostas Galatariotis, President of the Limassol Chamber of Commerce and Industry.
Good morning, dear members of the organizing committee of the first study group with industry, dear chair and members of the Mathematics for Industry Network, honorable speakers, distinguished local partners and supporters, ladies and gentlemen. It gives me great pleasure to extend a very warm welcome to all of you on behalf of the Cyprus University of Technology and to say how grateful we are to convene the first study group with industry in Cyprus and the annual meeting of the Mathematics for Industry Network that has just taken place at the university today. We are grateful for hosting this innovative event as 55 international experts in industrial and applied mathematics from 22 countries are here to solve real industrial and societal challenges faced by Cyprus and other countries. This will be done this week using the effective international practice of the study group with industry. The co-organization of the study group with industry contributes in technology and knowledge transfer between academia and industry and is thus totally aligned with the vision and the strategic objectives of the Cyprus University of Technology, namely to deliver cutting-edge solutions to challenges that industry, commerce, and the society face today while conducting high-caliber research. Study groups with industry provide a forum for industrial scientists to work alongside academic mathematicians on problems of direct industrial relevance. The study groups for industry were initiated at the University of Oxford in 1968, and they have since then expanded in more than 20 countries. The success of the European study groups with industry, in which problems presented by industry are used as a basis for mathematical research, is demonstrated by the extent to which the unique format has been adopted around the world and is now extending into other areas where mathematics may be applied. Today, the MyNet is a network of 31 countries funded by the EU COST program, which aims to facilitate more effective widespread application of mathematics to all industrial sectors by encouraging greater interaction between mathematical scientists and industrialists. We are proud that the chair of this event, Dr. Katerina Kauri from our university, is also a member of MyNet. We're also very happy that the chair of MyNet, Dr. Joanna Jordan, is with us today, and we're looking forward to hear more about the network from her later on. With us today, you also have two other leading international experts in industrial and applied mathematics, Professor Paul Hjorth and Dr. Hilary Ockendon, who will relate to us effective international practices for connecting academia with industry through the mathematical sciences. The presence of internationally distinguished academics at the Cyprus University of Technology to tackle real problems and challenges facing industry and society as a whole supports the continuous efforts made by the university to link the research and academic community with the productive sector of the country's economy. We're looking forward to following the process of implementation of applied mathematics and operational interface in theory and practice in this important event that will show one more time the importance of the use of mathematical sciences as a unique and innovative, useful tool solving local, industrial, and social problems. So at this point, I would like to thank Dr. Kauri for her valuable contribution to the organization of this event, the major sponsor KPMG, the Ministry of Energy, Commerce, Industry and Tourism for making this event possible under its auspices, and all our supporters, the University of Cyprus, the Research Promotion Foundation, Limassol Chamber for Commerce and Industry, the British High Commissioner in Cyprus, Talos Limited, the Cyprus Mathematical Society, the European Office of Cyprus, the Liaison Office with Industry and Society at the Cyprus University of Technology, and the Cyprus Tourism Organization. We embrace this initiative and we would like to see its organization, its annual organization here at the Cyprus University of Technology. I want to thank once again all the participants of this event, and I extend my warm wishes on behalf of the Cyprus University of Technology once more for a productive and successful event and a pleasant stay in Cyprus. Thank you.
Mr. Konstantinos Karagiorgis now.
Thank you very much. Distinguished guests, ladies and gentlemen, it's my great pleasure and honor to welcome. Thank you. It's my great pleasure and honor to welcome you all to this important event, the first study group with industry ever organized in Cyprus. Following the valuable tradition of study groups with industry, as Andreas has mentioned, initiated by the University of Oxford in 1968, this event marks the beginning of Cyprus in adopting an innovative approach when it comes to solving real industrial problems of great significance through the collaboration of leading research applied mathematicians and industrial representatives. First of all, allow me to convey the Ministers of Energy, Commerce, Industry and Tourism warm greetings that at the same time his apologies for not being able to be here with us today. It's true that organization which sees opportunity through innovation in the current fast-changing business environment will not only survive, but they will successfully compete. It's important, though, to use innovation in a strategic and systematic way as a key method for developing innovation cultures, accountable business management processes, and global industry ecosystems. We need to ensure that our people in the private and public sector develop and create trust, have the ability to come up with creative ideas, and are encouraged to implement them. Innovations enable organizations to achieve greater business outcomes, especially through engaging and inspiring people to create, invent, and innovate new products, processes, and services, achieving business growth goals and improve bottom-line results, competing successfully to respond to industry disruptors, increase market share, and extend product life cycles, responding quickly by developing the internal capability in both human and technology resources to change directions and do things differently and more effectively. I assure you that the government is also aware of the innovation opportunities. The intention of the government is to substantially enhance the overall innovation efforts by facilitating, supporting, completing, and connecting both existing and new European national initiatives towards this direction and integrate them under one banner strategy for industry, with the aim of modernize and digitalize industry. Enhancement of digital and industrial skills, integration of key enabling technologies, investment in research and innovation are means that shall be utilized for the development of highly competitive, high value-added, innovative products and services that will contribute to the extroversion of Cyprus business and boost export of our country. In relation to the above, the government has proceeded to actions such as the encouragement of the creation of the Cyprus Science Technology Park, as this is expected to be an important infrastructure for the promotion of research, innovation, and high technology in Cyprus. Furthermore, a national policy statement for the enhancement of entrepreneurship ecosystem in Cyprus has been formulated and is under implementation to create a more supportive ecosystem to innovative companies, startups, and entrepreneurship in general. In addition to the above, the government has prepared a new tax regime. At the same time, the government is promoting the creation of alternative methods of financing, mainly through the creation of financial instruments like venture capital, crowdfunding platforms, and business angels, which are expected to increase availability of finance for innovative high-risk companies and startups. In this effort, the government will focus towards the creation of efficient and effective mechanisms to engage in active private funds in the real economy. Ladies and gentlemen, this is an ongoing effort. As government, we realize the need for a more innovative method to solve problems and drive our country towards further growth and development. That is why your efforts are not only complementary, but invaluable to our efforts. Before I close my short welcoming speech, please allow me to express my gratitude to the organizers for their excellent work and initiative, and extend my acknowledgement to all those involved in the organization of this event. Thank you very much.
And now Mr. Kostas Galateriotis.
Distinguished guests, ladies and gentlemen, it is with great pleasure that I'm addressing today, on behalf of the Limassol Chamber of Commerce and Industry, the study group with industry, the first of its kind in Cyprus. To begin with, I would like to congratulate the Mathematics for Industry Network in Cyprus and the Cyprus University of Technology for this initiative of bringing to Cyprus an event which has been held elsewhere with great success for nearly 5 decades, the starting point being Oxford in the year 1968. The study group with industry constitutes an effort to effect solutions of problems confronting the business sector, employing towards the attainment of that goal the expertise of outstanding scientists with a mathematical background from both Cyprus and abroad. This objective is fully compatible with what we do, because our role as a chamber is primarily focused on promoting solutions to the problems facing our members. Any methodology and any ideas in that direction are, of course, welcome. When the Cyprus University of Technology was set up some 12 years ago, with the active support of our chamber, one of our top aspirations was the establishment of an optimum use of a direct line of communication between industry in the broader sense of the term and academia. In a world where research and development and innovation have been increasingly taking center stage, it was not difficult to discern that one of the best ways forward was exactly the connection of scientific knowledge with the actual production process. I believe that the event we are inaugurating today, where I'm pleased to note that 2 of our 4 organizations that have been chosen to present problems before the experts, Engino and Party Eyes, are members of our chamber, is fully in line with its concept. Surely, the very idea of a purely mathematical approach to solving business problems may strike one as essentially new to Cyprus. But we need to be open to the new, as always. What matters is the final analysis. What matters in the final analysis is not so much the method as the outcome. Taking this opportunity, I would like to express our many thanks to all the academics who eagerly agreed to lend us their expertise for their realization of the project. And of course, a very warm welcome to Limassol, to those of them who have traveled to Cyprus from abroad for this purpose, as we are pleased to be having with us today experts from 17 countries. I'm sure that we all look forward to the actual findings of the experts, what solutions they came up with for the specific problems, how these solutions will be implemented. Thank you very much.
We thank our distinguished guests for their addresses. Thank you. I would like to again warmly welcome all of you on behalf of the organizing committee of the first study group with industry. We're very pleased to have with us, as already mentioned, academic colleagues from the Cyprus University of Technology, but also from 26 other countries. Many of these countries' representatives will stay on for the whole week to work with us on the 4 industrial challenges we have selected for the first study group with industry. I would like to thank at this stage our major sponsor, KPMG Cyprus, who is co-funding this first study group with industry with the Mathematics for Industry Network. You're going to hear many things about the MINet later on. So I will give you some information about the study group with industry in Cyprus, and then 3 international experts will share with us effective international practices from abroad. And then we're going to have also a question and answer session. You can ask any question you want, and hopefully we'll have a short panel discussion on how we can better bridge academia and industry in Cyprus. So with this, I would like to start my talk.
A short talk will follow by Dr. Joanna Jordan. Dr. Jordan,
Okay, so the first study group with industry, it's very important to note that it is also the 125th European study group with industry. We abbreviate this ESGI. It's an abbreviation you're going to see later on in the talk. So as already mentioned, besides my Cyprus University of Technology affiliation, I'm a member of the Mathematics for Industry Network. So what is the study group with industry? It's a week-long workshop where teams of mathematicians and other researchers with advanced mathematical expertise, this means not only mathematicians, but also engineers, computer scientists, physicists, then get together and they solve industrial problems intensively over a week. Industry, it has to be noted that it's not just, if you allow me the Greek word, biomechania, it's any activity of social or economic value. So for us, it means commerce and also means societal problems, and many study groups around the world have solved cutting-edge society's problems, actually. It was initiated, the study group format, in the Oxford University in 1968, has gone to more than 20 countries by now. It is regularly organized in 14 countries now. And Dr. Hilary Ockendon from Oxford will share with us later on the history of studying groups around the world. The European Consortium for Mathematics in Industry has supported this format in order for it to move forward. And we also have with us today the Executive Director of ECMI, the European Consortium of Mathematics in Industry, Professor Paul Hjorth, that will tell us more about ECMI. So the numbers are impressive, as I already said. There are more than 14 countries. There are more than 600 problems that have been solved in this format, and many long-term collaborations that emerge from those problems. And why do we do it now in Cyprus? Well, it's one of the most effective practices right now for connecting academia with industry, and we need this in Cyprus, so we have it here now. And what is the key? Well, the key is intensive teamwork. People get together in a room for a week, and they have diverse mathematical expertise, so they bring their different points of view together, and they create something great. It's amazing how much you can do in a week if you are working as a team. And, more teamwork from previous studying groups around the world. And here is the 100th ESGI that happened in Oxford in 2014. You can see within 2 years, from 14 to 16, we have 25 such events that happen in Europe. So it's a booming area right now. And Dr. Ockendon will tell us more about the future of this area later on. And actually, the European Science Foundation has recognized that, and there is a forward look series, Mathematics in Industry report, that says that mathematics has been used in many industrial sectors, but there is room to use it in more sectors in order to become a leading economy. So the first study group with industry in Cyprus is happening this week. It's starting now. It's finishing on Friday. The organizers are the Mathematics for Industry Network and the Cyprus University of Technology. Where it is happening, the first 3 days we are here, and the Thursday and Friday we are in Posidonia Hotel. The problems are 4 from diverse sectors. The problem solvers are 52 researchers from 17 countries. Of course, it has to be said that we have more countries here now due to the annual meeting of the MINET that happened just before here in the Cyprus University of Technology. The major sponsor, I already thanked them in the beginning, is KPMG Cyprus, who is co-funding along with MINET. Supporters, they are quite numerous. Already our rector has mentioned them and thanked them, so I would like to thank them as well. The Mathematics for Industry Network, very quickly, before Dr. Jordan takes the floor and explains more things, it's a network of 31 countries. And the whole point is to spread this idea that mathematical sciences are a very useful tool for solving real problems. If we are scientists, we are usually faced with the idea that mathematics is not useful. It is, and it's a very valuable tool. In Cyprus, there are 2 representatives. It's me and the vice chair of the organizing committee, Margarita Zachariou, there. And as I already mentioned, the annual meeting of the network happened just here before. The 4 problems, very quickly. You have to stay tuned with us. 2 to 4 p.m. We're going to have a 30-minute presentation for each of the problems, but the headings are the following. And Gino is bringing with us the question of, if you have a fixed number of pieces, can you increase the number of combinations of toys? And also one still unresolved problem, also for Lego, is whether you can automatically generate built-in instructions. Mr. Sisamos was somewhere here before. He's an expert in this, and he will share with us what is the problem with this at 2 p.m. The party ice problem is about optimizing the distribution of ice across Cyprus. Water Development Department will also have representatives here now. They want to see if the sewage pipe inside the aquifer of Yermasoyan breaks, what will happen? How can we model, how we can predict the damage? And the Transportation Organization of the Nicosia District is bringing a hot problem for Cyprus, which is how to optimize bus routes. Some people from Cyprus laugh now because almost nobody, sorry Andreas, takes the bus. So they will be very helpful if we give some help with that. The study group process, as I said, is 5 days, intensive teamwork, and I just want to say here that on Friday, the closing event is also open, and you can come and see the outcomes of the process. We close the doors at 4:30, we open again at 12 at Posidonia, and there you can come and listen 30-minute presentations on the problems. Before the ESGI, there is a lot of work that is involved because we have to identify the problems. All our supporters helped in some way to talk to people and identify the problems. Some people in the end decided not to bring the problem. So it's a whole search that has to happen. And this was materialized through a mentoring board that helped us select this problem, international experts. And also we had to identify the academic participants to solve the problems. And of course here MINET comes and helps a lot because the meeting happened here and we could draw people from the meeting to stay on for the whole week. Organizing committee, I already mentioned my colleague, Dr. Margarita Zachariou from the Cyprus Institute of Neurology and Genetics. We also have Dr. Paul Christodoulis, unfortunately not here with us today, to another cause meeting actually, and Dr. Andreas Kyprianou from the University of Cyprus. And the scientific board is all these experts that helped us identify and finalize the problems. After the ESGI, the team writes a report to share with the company. Everything that happens during the week goes to the company. And of course, after that, the real challenge is to go and investigate and facilitate long-term collaborations. It's not enough to just get all the experts inside the room for a week. You need to translate this into long-term collaboration. So there are various forms to do that. Many people here are experts in academia industry liaison. So I'm not saying something new, I'm just reminding you for those that don't know that we can do joint funding proposals, we can do consulting agreements and industrial sponsorships, we can place our students inside the companies and do internships. We can translate a company problem into MBA, MSc, PhD project, and we can also, sometimes the company after the studying group takes the results and go into their R&D department, and they don't want to talk to you anymore because it's usually an IP issue. They use it and then they take it up themselves. I will finish my talk with a very famous case study. It's one actually we used also, we went to KPMG to pitch the studying group. And it seems that everybody loves this, I love it as well. It's about Philips, the famous Philips company, bringing to the Irish studying group in 2012 the following question. We have noticed that the taste of our coffee is related to how the coffee bed is created when the filtering process is happening. Can you use mathematical modeling to explain this correlation? So basically, indeed, the team during the week transferred knowledge from hydrology and geology about how river flow and rain is affecting the soil's morphology. And in that way, they came up with an initial model. The company loved this approach, and they continued their collaboration long-term with the Mathematics Applications Consortium for Science and Industry, MAXI, in Ireland. And long and behold, 4 years later, after many publications and in this ongoing collaboration, BBC picked up the story, and they are talking about maths finding for you the perfect cup of coffee. So that's great. We hope to have some results that are equally relevant. And of course, for us, it's nice to hear, okay, a better cup of coffee, but for Philips, it's millions of euros that they save through this way, right? And what is the vision? We want to establish studying group as an annual event. We need help from everybody in this room and beyond to achieve that. And basically, a question is how you make these long-term collaborations happen after the week. So we have obviously the liaison offices in the universities. There is a lot of discussions going on right now in Cyprus. How do we make this connection better? How do we keep ongoing contact with the industry as academics? So for me and for us as an organizing committee, we have in our mind that this kind of center, maybe it's a Mediterranean one, I don't know, can identify these challenges all year round. They can promote also interdisciplinary collaboration, because another important point is you talk to the other colleagues in the other departments too. And also, we want to demonstrate the value of these solutions to the public. It's not enough just some people in the room to say something that is very useful. They have to share it with the world. So with that, I would like to finish my talk. Thank you again all very much for being here. Sorry. Right.
A short talk will follow by Dr. Joanna Jordan. Dr. Jordan leads the commercial activities and day-to-day operational management at the University of Bath's Institute for Mathematical Innovation, IMI. Prior to joining IMI in 2015, she managed the Mathematics Application Consortium for Science and Industry, MAXI, at the University of Limerick in Ireland. She also holds a PhD in Industrial Mathematics from the University of Bristol. Jo chairs Mathematics for Industry Network, MINET, European Cost Action, a consortium of over 30 European partners promoting industrial mathematics across Europe. Thank you.
Thank you very much for the nice introduction and the opportunity to speak this morning. I'll just load my slides up. So congratulations to CUT for hosting their first ever study group. It's an absolute pleasure to be here. And thank you very much to the organisers for the opportunity to speak this morning. So my talk actually falls into two halves. So I'm going to start just by outlining the Mathematics for Industry network. And then Katerina has also asked me just to say a few words about my home institution at the University of Bath as well. So I just wanted to say that on the front of my slide, these are all pictures from industrial projects that I've been involved in setting up over the last few years. So you'll actually recognise the filter coffee here, which is a study group that I chaired in Ireland in 2012. So we were very pleased to see that the press picked up on how maths can really be used in the real world just this year. So MyNet was an initiative which I set up in collaboration with ECMI a couple of years ago, because we saw this opportunity for European funding to help spread best practice in Europe of industrial maths, so how we can better promote partnerships between mathematicians and industry on a European and further afield basis. So COST's aims are to promote collaboration and share best practice, increase capacity and widen participation, which is perfect for what we wanted to do. We wanted to increase collaboration, as I said, solve real problems for industry, and also help train the next generation of industrial mathematicians in order to make this way of working sustainable. So I'm really pleased that since we've established this network, we've managed to engage 31 different countries from Europe, as well as some international partner countries and companies as well. So what's our vision and what do we do? Well, we've actually not got a massive amount of funding, I must admit that. It's seed funding. But maths is not expensive. We don't require particle accelerators or big, expensive labs. What we require is the brain power. So we need to make sure that we're getting brain power in the same place at the same time to work on real-world challenges. So we've got some funding to help support and sustain existing activities. We don't want to reinvent the wheel. We want to make sure that we're supporting activities which we know work. It's been mentioned previously, these European study groups with industry, with problem-solving workshops, have been tried and tested for over 40 years. It works well, let's do more of them. What helps, though, in setting these kind of workshops up, because it's a big undertaking, as I'm sure Katerina and Margarita will be willing to tell you, is to support some feeder activities which can help in setting up this kind of week-long workshop. So one activity is industrial workshops, so a day-long workshop where you can get together a particular company sector, or you can focus on a particular technique and you spend a day working on that activity, knowledge exchange and all of this good stuff. Another activity we support is in helping train the next generation of industrial mathematicians, which are maths modelling weeks, which are almost like study groups, but the problems are a little bit more well understood in advance, so that experienced mentors can act as the industrialist and introduce students to this way of working. So we have funding for supporting more of these activities, and also for supporting activities which make the most of these as well, so we can capitalise on the many outputs that come out of these workshops. So we have funding for what in cost speak is called short-term scientific mission, what in English actually means research visits, which I know Katerina has used to come over to Oxford on a couple of occasions previously. And the idea is that these research visits can be used to follow up really promising problems that arise at study groups, so whether there's a scientific output to come out of it, some kind of publication, or whether it actually help to work more closely with the industrial partner following this workshop in order to make sure that all the good work that was done during the week can then be implemented in practice. So as I said, we have just over €500,000 over a 4-year time period. And we have seed funding to support these activities. So in the last year, we supported 6 industrial workshops, 2 modelling weeks, 5 study groups, including the first one in Italy and now the first one in Cyprus, and also 12 research visits across Europe. But what I will say to you is that this funding is now open for application, so please make the most of this. We have very simple funding applications, we've tried to keep it as light touch as possible on our website, and these are open until the 3rd of January for your application. We tend to have these calls every 3 to 4 months, but I'd encourage you to apply early. We've got funding which we want to use next year, so please use this for the benefit of industrial maths in Europe. So that is my short introduction to MyNet. I also just have a few slides on my home institution as well. Very much. So I'm based at the University of Bath's Institute for Mathematical Innovation, which was established early last year to stimulate more industrial and more interdisciplinary maths, recognizing that maths can add huge value not only to industrial problems, but also to other disciplines as well. So we've grown quite a lot since we set up. So we have some distinguished scientific directors, a professor of data science, and a prize fellow as well. So I'm a mathematician turned manager. So I manage an operational team, including our very able project manager, Philippa Vance, who's here today, and a commercial research associate team, which I'll tell you a little bit more about. So in the Institute, we run a range of different activities. We have some internships for students, and we support workshops and academic visitors. But what I think is really novel about our setup is our team of commercial research associates. So these are individuals who are kind of halfway between a postdoc and halfway between a mathematical consultant. So they all have a PhD either in mathematics or in statistics and industrial experience. Their remit is to solve real-world problems from industry or from other subjects. But they work on short to medium-term projects, and their main metric is not by publications, but by satisfied customers. So in these slightly unusual roles, they get to see a whole variety of different problems and different projects. And we're just starting to see the benefits of these now. So, because often it takes just a small piece of work just to stimulate a new collaboration. And this can be both academic or industrial. So we typically combine CRA time, commercial research associate time, which is postdoc rate, with more expensive and more in demand academic time. Because our CRAs don't have the same commitments of publishing papers or of teaching or of supervising PhD students, their time is more readily available, so we can start up projects really quickly as well. So you may say, well, why bother working on short-term projects? Well, as I said, this investment on a short-term basis can stimulate much longer-term engagement. So I just wanted to give you a couple of examples of how we've seen this work, and this is really only over the last year to 18 months. I think we've just scratched the surface of where we can add value. So earlier this year in January, so Airbus took part in an industrial workshop run by the Doctoral Training Centre in Bath. And this was a week-long, kind of like a cross between a modelling week and a study group. And they had lots of interesting projects, but none was directly suitable for a PhD student to take up on a 4-year basis. So what we were able to do is just do a small amount of consultancy. So there's about 6 weeks. So my colleague Catherine from the Commercial Research Associate team, a statistician and a mechanical engineer, worked closely together with the industrial partner. And this investment of a 6-week project meant that we, not only in solving their problem, is we were also able to scope out a longer-term interdisciplinary PhD project. So just adding 6 weeks to a 1-week workshop, and you're able to get your 4 years funding to stimulate that interdisciplinary PhD. So another project we're working on at the moment, so this is a Research Council funded project. So a big thing at the moment in the UK is that a lot of the research funding has been diverted to this Global Challenges Research Fund. And chemical engineering had a project on development of water treatment units. Now, they've got some lovely experiments, and they had a collaborator in civil engineering who was able to 3D print these things. But what they really needed is a mathematical modeler to describe using equations how the water actually flowed through this equipment. So my colleague Ellen is working with a mathematician in our department, civil engineer, chemical engineer, and an economist who's going to evaluate kind of practical feasibility of launching these kind of devices in the third world to take this project forward. So just a small investment of maths time is actually going to have a big impact on this project, and it's going on at the moment, and I'm hoping that maybe in a year or two's time I'll be able to tell you what it leads to, or even be able to put up a BBC News article. Another one, I really do like this. I think it captures the imagination in the same way that coffee does, but chicken maths. So my colleague Lorna from the Commercial Research Associate team worked with Happy Eggs on evaluating what consumers think are important for making happy chickens in order to lay the most eggs. So this collaboration then stimulated further engagement, which is on chicken beaks, because chickens can peck each other, and because they tend to peck to eat their food, but that also unfortunately means they tend to peck each other as well. So at the moment, their beaks just get cut off, which I think is terrible. But what they want to do is image these beaks and get a better understanding of which chickens have the sharper beaks, and then see if they can breed this out. Another thing I learned about chickens just a few weeks ago is they sleep with half their brains. Who knew? This is so clever. So Lorna has got an interdisciplinary PhD project out for advert at the moment on mathematically modelling chicken sleep and how they sleep with one side of their brain or the other. So this actual consultancy work was half a day to start with, is then leading on to an undergraduate project which is over 3 or 4 months, and then is going to lead to a 4-year PhD project. So just that initial investment, and all of these things might not have happened otherwise. So I think that's really what gets me out of bed in the morning, is working out where these challenges lie and where mathematicians can really add value. So I'll just give you a shameless little advert for a workshop that we're organising in Bath in January. If you have a good time this week at the Study Group with Industry in Cyprus, we're holding a very compact 3-day themed meeting on agri-food in Bath, and registration is open until next Monday, the 12th of December, and it would be great to see some of you there. We've got the problems just presented on our website, so you can have a look and see if any of them are of particular interest to you. Thank you very much.
And now, Professor Paul York, Executive Director of the European Consortium for Mathematics in Industry, ESGI. Professor Paul York is an Associate Professor of Applied Mathematics at the Department of Applied Mathematics and Computer Science in the Technical University of Denmark. He is the Executive Director of the European Consortium of Mathematics in Industry, ESGI. Professor Paul York received a Master of Science in Mathematics from the University of Copenhagen and a PhD in Mathematical Physics from the University of California in San Diego. He has been organizing annual study groups with industry in Denmark since 1998 and has participated in more than 30 study groups with industry across the planet. In addition to industrial mathematics, his research interests include dynamical systems and the study of many body systems. He has lectured at the Open University in Copenhagen and at the Royal Danish Academy of Science and Letters. He's a very old man, so please be gentle with him and only ask a question at a time. Thank you.
That was not supposed to go on the... Can you hear me in the back? Excellent. Thank you very much for the invitation to say on this occasion, my first visit to Cyprus ever, and I hope not my last, a few words about ESGI. So there are a lot of acronyms floating floating around, and many of them will have an E for European, an M for mathematics, and I for industry. But here in our logo, you can see the C is taken out, and this is because the operating term here is consortium. What does consortium really stand for? Well, I looked it up, and it says it's a vague term. It means common destiny or common fate or common purpose, and so I think it's not a bad name. There's a website, of course, and on this website you can see the mission of ESGI, and this is to promote and support mathematical modeling. Also, it is to educate industrial mathematicians. So if there's any single point I'd like you to take away about what it is in particular that ESGI does among the many players, is that we have a large stake in looking after the educational aspect. And of course, it's all supposed to be done. The E is important, so many people take it for granted. We know in this day and age you should not take Europe for granted. It is important, and it was from the early beginnings of ESGI something that was important, and a good story can never be told, I think, too many times, and so I'm repeating what Joe has repeated, and what Hilary Ockendon will also say in the next talk after me, that it really began with the with these study groups with industry pioneered by these two Oxford professors, and in particular, I like the formulation here that industry contacts are challenging university mathematicians to solve their problems, because this is really, I think, one of the spirits that drove the original effort. And as you've heard, because it was a good thing, it was a successful thing, it took off, and other applied mathematicians in Europe started coming to these meetings and taking an interest, and in the mid-1980s they decided to form this union, this joint spirits organization called the European Consortium for Mathematics in Industry. They saw an interest in shared standards for education, and also, of course, shared experiences about how to deal with these particular problems. And so the ESGI master degree was designed, and it has since been modified and kept up. So the member universities, because ESGI is a collection of university sites, of ESGI member sites, offer a degree that those who take it can say, I have taken the ESGI degree, and they get an ESGI certificate. This started from humble beginnings. Can you see the green spots in the back of the room? Can you see that there are now more green spots on the chart? I'm not even sure this is complete, but the point is simply that because it's a good idea, you now have very many member sites. So education is an important activity, and time does not permit me, and this is not the place to go into how we distribute these 180 ECTS university credits in a master degree. But the aim is to, first of all, make good mathematicians, but it doesn't stop there, because after you have made good mathematicians, with a wide range of skills in, I would say, both pure and applied mathematics and also numerical skills, you have to throw in experience. So because we want to educate fully baked applied mathematicians who are ready to deal with industry, and this is a type of knowledge that that nobody is born with, and you cannot really pick it up from textbooks. There's really only way to learn how to do this particular type of applied mathematics, collaborative applied mathematics, and that is to do it. And so ECMI has a large educational committee set down to make sure that the program undergoes some quality assurance, but we also promote exchange of students between ECMI partners. So between all these green dots, we try and float students around so that they get this European experience, they get the international experience. And I think one critical activity is that ECMI does is we also help to organize these modeling camps, sometimes called baby study groups. I think Jordan mentioned it briefly. So every summer we send from many of the ECMI member universities students to one particular site where they form teams and work on industrial problems, often modified problems from the past, and from occasionally also brand new problems. And I know that students from my university have come back filled with excitement about how surprising it really was to them that the stuff they learned in their textbooks in Copenhagen was actually valid when they went to Sofia in Bulgaria or some other place where they found students from other countries who could also integrate the same functions and who also knew how things worked. And it was a huge surprise to them. So this is a very formative activity. So ECMI also organizes scientific conferences every other year. There's the ECMI conference. There was one this year in Santiago de Compostela in Spain, a very successful meeting. So the next one will be in 2018 in Budapest. And ECMI oversees disseminations, there are books and journals, there's a blog on the website where you currently can see new and fresh stories about industrial mathematics. And ECMI also gives out prizes for the best thesis work and other things in the field. ECMI supports special interest groups where researchers from across Europe can get together and maybe make joint proposals for funding from the European Union. So this is also an important activity within ECMI. And then, of course, ECMI oversees and warmly encourages these study groups from industry, which in some sense was the seed, the original core of ECMI. So here's one leading researcher, here's one who's trying to mimic him. But it's very hard to convey in photographs the excitement that you get. So if you have a photograph of mathematicians having a lot of fun and working, it's really just a bunch of people looking at the blackboard or on their papers. But I can assure you, not only is it useful, it's also a lot of fun to do. And I think here's my personal take on why both the companies and the academic side benefits so much from study grouping, because the short format of the study group, this 1 week hard focus that you can call a flash frying of a problem by independent expert, can be very useful. Sometimes it results in a no-go for the companies, and sometimes it ends up with them realizing that yes, they should hire an industrial PhD, or they should, but at the very least they will know what to do at the end of this week, and they get contacts with academics and the potential students, and vice versa for the academics. It's a way to test their skills. I mean, I educate engineers, and we have to sometimes try out our tools on the real world, and to see if we really can practice what we preach. And I can tell you that many exam problems have also originated in these study group problems. So from the academic side, it's useful, and of course, company contacts are always useful with a view to the future and places where students can do projects and so on. So I know they say there's no free lunch, but and there's no such a thing as a pure win-win. This comes close. And so in Denmark, we've organized these study groups for nearly 20 years, and we had one here in August. We also couple in a PhD course so that we can get PhD students to attend, and we find this is very useful. So I couldn't resist the temptation either to present just a few problems, but here's a couple of Danish problems from the many years, and as I think as Jordan pointed out, who knew? You get insight as an academic person. You get insight into so many novel and strange techniques that you had never heard about before in your life, and you wouldn't have a chance to hear about it if you weren't doing these study groups with industry. So here, in order to measure how old and repair worthy a road is, there's a method of pushing on the asphalt and with a predefined stress, and see how it gives. And there was a brand new startup company that came in with an entirely new measurement method based on lasers. So instead of doing it spot-wise with a fixed weight, this new company proposed to have lasers in a lorry and roll the lorry along the road. The problem they had was they had difficulty connecting their data to the existing sort of standard for data in the road directorate by the road authorities. So they needed help in doing that, and we gave that to them in terms of a very simple 2-parameter model, and they actually managed to break through, and the Danish government bought some of their vehicles, and they are now exporting for millions of euros to other countries this technology, which really provides massive savings for the road authority. And I'm always welcomed warmly when I visit the company because of this solution. And Grundfos is a Danish company that makes pumps. And they are so big that they actually have a research department that are looking into novel types of pumps. And they came across this patent from 1932, and these are the original patent drawings. And I know there's not much light here, but that sort of helps my argument. But the argument is these drawings are very difficult to look at. How do these pumps work? So this was the first question they had, is what's going on here, And then can you describe it mathematically so that we can actually design and build these pumps and modify them to our particular needs? So clearly we needed geometers. So we had the geometers look at it, and it turns out they are actually modifications. They had never been made. And that was because you need very high precision milling in order to actually make these pumps, and they couldn't do it in 1932. Now we can. So it's a modification of, I think they call it an Archimedes screw, where you have a spiral motion that draws fluid up. But here, the spiral motion is very advanced. So you can see the purple liquid being drawn in here and then squeezed up through the channel by means of a rotating shaft. And there's a lovely history of geometry on how to describe these. And we provided this to the company, told them what they should watch out for in the shape of these things, and they were 3D printed even during the week, and the company was very happy, and they have come back since. So my last problem, inspired by Jordan's chicken, is a problem from one of the UK industry. I think you were a PhD student at the time when we did the penguins in Bristol. So Bristol Zoo came to us with a problem that they were unable to hatch eggs from this Spheniscus demericus, threatened species of penguins that live on the south coast of Africa and also in Bristol Zoo. So so they took the eggs away from the penguins and put them in in hatching machines, but the hatching machines were set for chicken eggs, and they couldn't hatch the penguin chicklets. So they needed actually to have knowledge about why is it that the penguins sometimes turn their eggs. Because something is happening with the gravity and what's going on inside the eggs that needs to be tuned very precisely. And so this is a sort of a private joke in the business, but we actually did consider a spherical egg here with the various contents, and we actually managed to solve the problem during the week. And here's, as you can sense, the mood was very good. Here's the first page of the report, and I don't know if Bristol Zoo read all the lovely detailed about shear flow and all the technical formulas that were in the report, but it ended up with a very precise recommendations for how to set their hatching machines, and the result was unmistakable because the mathematicians became sort of godfathers of a new generation of penguins, and so there was one species that didn't vanish this time. Okay, so that was just a brief, quick going over, and I should point out here that study groups. After some time, study groups become a fixed tradition because both industry and applied mathematicians think it's very worthwhile. But it's also important to break in new study groups like this one. And so this couldn't have been done without help from EMINET because ECMI provides sort of psychological support, but you also sometimes need financial support, and this has been invaluable with EMINET, and so I will close briefly by pointing to these other players, and you should also know about EU Mathsin, which is a non-academic, really, organization that spearheads the rapid exchange and rapid communication between mathematics and industry, and works on building an e-infrastructure. And so you can talk to Will Schilders, who's in the room, and here's the website. And EU Mathsin is incredibly useful to have as a sister organization. And these good messages, why we are doing all of this, has been said many times. I will not spend too much time on it. Applied mathematics is a fundamental driver for industrial innovation. But it's also important to view how we make sure that a generation from now, and ECMI has existed in one generation already, that it also exists in a generation into the future, because face it, the problems for society and industry will not get fewer, they will get more, and we need applied and industrial mathematicians to solve them. So I think that was my spiel. Thanks to various people who have educated me on the subject and brought me into ECMI, and I think I'm out of time. Thank you.
Now, Dr. Hilary Clinton will explain how the idea of mathematical scientists working directly with industry has developed dramatically over the last 50 years. Dr. Clinton has spent her academic career in Oxford University, where she was involved in the growth of industrial mathematics pioneered by Alan Taylor in the 60s. She attended the first mathematical study group with industry in 1968, and since then has worked on many industrial problems. Her particular interest is in the use of continuum mathematical models for solving real-world problems. She is joint author of 2 textbooks on fluid dynamics. She was the acting director and subsequently the director of the Oxford Centre for Industrial and Applied Mathematics from 1994 to 2002, where she is currently an emeritus member. She was on the Council of ECMI for 10 years and was the ECMI president from 2001 to 2003.
Thank you very much. I'm very glad to be here. I have to say that it's clear that the person who should have said they're very old and and you've got to be gentle with them is not Paul, but is me. Anyway, it's getting late. I can hear the lunch next door. So I just would like to tell you that I'm going to be, they've really said everything I'm going to say already, so I think we can be quite quick. Right, so we'll move on. So 50 years, that's about the length of time that industrial maths has been going on. Not, of course, that mathematicians weren't doing industry before, weren't solving, but it was much more random and occasional, and it has, I think, in the last 50 years become quite well organized, and people have got, as we see, get together and do it in a much more systematic sort of way. I put down here the things that I think are relevant to the last 50 years, and of course computers are the other thing that have happened really in the last 50 years, and I think that's not a coincidence. The fact that computers, I think more than 50 years ago, probably applied mathematicians were doing what their best to be the computers, and the great thing about computers is first they came and took the boring bit out of applied mathematics, But then they spread and spread, and everybody had them. So that meant that as well as that, everybody had computers, and so everybody could make a model, and so the areas in which maths was relevant got much bigger, and the industrial mathematician has evolved during these 50 years to be someone who doesn't just sit in an ivory tower, but who works with an applied scientist, sets up a model, and has a toolbox of skills, because at the beginning you never know which one you may need. And that's, of course, the other reason why we have study groups where we have a lot of mathematicians together, because that way we have a lot of expertise and we can get the best one into the right place at the right time. Now, I want to know whether you've been listening. Before I go to the next slide, who knows? Where did all this study group stuff start? Does anybody know? Shall we say Oxford? And what was the date? 1968. There we are. Right, we're sort of agreed. There was a little precursor to 1968, which was that in 1966, the Royal Society of London wrote a report saying mathematicians should try to be more useful. I don't know how far it went, but it went around the UK, and how the first study group started was that Alan Taylor and Leslie Fox applied for money, and they used this argument about the Royal Society report to get some money in order to run these study groups. And the remarkable thing is how similar they were, 40 years ago, and they were still the same thing we have now, much smaller. The first one, I think, was perhaps 20 people compared with the sort of numbers we have now. No, perhaps even less, more like 10 perhaps. But otherwise, this idea of putting people in a room for a significant time together to get things going has really stood the test of time. So I've just written down here a very few, a few milestones in the study groups, because although other things happen as well, there are other ways, as people have said, of doing maths in industry. The study group is what we're here for today, and it illustrates, and you can see that it was quite slow to begin with. The first UK study group got out of Oxford was 20 years after they'd started, so they'd been every year in Oxford. And then after 20 years, they started wandering around the country. The first European one was the Danish one, which was 30 years after we'd started them. So it was going very, very slowly, this increase. But then, since then, it has really gone like that. And there is an enormous increase in the numbers. And these numbers are not too far out from numbers other people have said, so that's good. So this is just a slide on what has changed in the kind of applications that we started off doing kind of engineering problems, and what we have got to now is much wider applications. Then there was developing algorithms. A lot of that is all now built into software of various kinds. In the 80s, stochastic problems stimulated by finance, that was very important and has become a very big growth area. Inverse problems and parameter identification from things like the oil industry, who are always wanting to know, what's going on in places you can't get to. And more recently, networks, data, multi-scaling, and discrete problems. And more applications in different areas like social science, environmental, And medicine is one that I meant to write down and forgot. This is about training. We've mentioned that several times already, that training has been has turned out to be, doing industrial maths, I think, is very good training for students. It makes it more entertaining, and it prepares them much better for a job in the big wide world. We've already, I think, mentioned all these things like modelling classes, modelling weeks. Study groups, including students in study groups, is very salutary. I think it's good for them to see that their professors are sometimes wrong, and it's good for the professors to sometimes find that the students have a better idea than they do, new idea at least. Anyway, so I think that what we've all said is that maths in industry is now an accepted subject. It started gradually and is now thriving. What are the important things in that? Well, one is, I think we've almost won the battle to say the only thing that actually having relevant research does now get you some credit. It used to be that academic papers were the only measure of how well an academic did. But I think now research councils and other people who are assessing academics think that being relevant and going out is important, and not just for making money, but also for developing new ideas. And of course, students want courses that lead to jobs, and it has, I think, now been absolutely shown that academic areas open up because of the stimulus of real problems. So here are some examples. We've had some very concrete examples already. These are sort of more general. There's a thing called the pantograph equation, which is a functional differential equation. And it has this name because it came from an original problem from the railways about the waves in their pantograph, which is the thing that hangs over the top of an electric train. And that has generated a vast amount of absolutely straight academic research. And then just here are some other ideas that violent impact in liquids is a lot of work being done on that. Auction modelling for for radio frequencies has become very big business. And these are also the sectors in which we can get applications from government and defence, and not just conventional engineering and manufacturing type of industry. And of course, free boundary problems, another big area, and inverse problems that I mentioned before. So it's now absolutely accepted that we're not selling our souls for the sake of a bit of money, but we're actually getting better and doing more interesting mathematics. These are the benefits for industry, which I think we've heard before. I just stress two things. One is that it isn't always solving the problem, but if you make a model, you understand what the important things are. Students, of course, are always very attractive to industry because they're the employees of the future. And SMEs, the small and medium enterprises, they're often very short of being, they know one thing usually and don't have a research department. So if one can come to a study group and get a little bit of expertise, a little bit of help, that may be very helpful for them. Or just go to their local. They don't have to do a study group, they can do it some other way. But they should be able to go to their experts. Right, let me just try and think about the future. So what we've heard a lot about today is about networks. Right? MyNet, ECME, all these things. APCMFI is one they haven't mentioned, which is Asia Pacific Consortium for Maths for Industry. And that's a new one that includes sort of Japan and Australia and that sort of area. So we're working together to be more efficient, to avoid duplication of effort, but also to help with, but also to build on what's happened before. You know, we don't want to waste what's been done earlier. And we do want to be able to know where the expert on something is, or did a problem from another country appear some time ago, can we pass the information over? I think maths is quite lucky here because it's quite far from the development stage, and so the IP difficulties are relatively small. You can pass information about. We don't have a lot of patents that are relevant. And then there's one other thing. There's this idea that's come up, but I'm now going to quantify it. Have you heard of a TRL? Who has heard of a TRL? Good. So this is a new thing, a technical readiness level. And they start at 1, which is not very ready. That's an academic sitting there doing their research, which may have been stimulated by industry, but is not anywhere near industry at this moment. And technical readiness level 8 and 9 is actually when you've got a concept, you've taken it through a lot of testing of both the software and the model and the experiments goes on in the gap in between. And when you get to 8 or 9, you're actually going out and making the bit of kit or selling it to the customer or whatever it may be. So there's quite a big gap in the middle. And that's, I think, one of the problems. And that one needs to think about how to do. Well, one way to do it is what one might call a hub. This is a bit like what Jo was saying about what her institute in Bath is doing, that they have people who can concentrate on a problem and will be able to talk. In the UK, we also have a thing called the Smith Institute, which employs a lot of people called technology translators. And what they do is sit, I think, between the academics and the industry people and can talk to both and can do some of this middle stuff. And they work as a hub within the UK, talking to people in a lot of different universities. And I think there is a need for that in the future now. And then in the middle I said bilateral funding, by which I mean it's very hard to get industry to pay for TRL 1 and 2. It's so far away from what they want to do. They might pay for a student, they like students, and that feels like a good thing to do. But they don't much want you to pay for you to do a bit of research unless it's very obvious it's going to do something for them. And so we do still, I think, need some sort of government underpinning for this activity, or some which may come through the universities, it may come through the research councils, who knows, but that's what we mean here by bilateral funding. So, those are the two things that I'd say at the end, that we need to develop these people who stand between the mathematicians and the final result, and we mustn't forget that we're doing good things at both ends. Okay. I'm going to stop there, and we can move on to the next bit. Is that okay?
follow-up activity. So how do we enable the process between the company and the researchers to continue developing the ideas that they have generated within this week? What would be your recommendation in a place like Cyprus, where this is a new event and it has just started now?
Who would like to speak? You're right. I mean, that is, I think, the great problem. And also because you've come here and you've spent a week and, you know, you've done that. And it's very hard to keep the momentum up afterwards. But I think that it's very important that you do. I don't have an answer for that moment. Do you have an answer?
Yeah.
Good.
So one mechanism that we found particularly effective in Limerick is making sure, and Margaret Turn encourage you to do this, that you had a deadline for submission of the technical report, that it wasn't left to drag on several months after the workshop, that it was literally finished a week or two after the end of the workshop, because it's capturing the week that was done during the work that was done during the week rather than that. And then make sure that there is someone local who understands that problem and what was done during the week, who can then lead a presentation on the site at the company reasonably soon after the workshop. In that way, the result gets disseminated not just to the industrial representatives who were here during the workshop, but also to their colleagues as well. And in that presentation, you can summarise the work that was done during the week, the recommendations, and then offer a menu of different mechanisms in which how you might be able to work together in the future to follow this up. Any other questions? Yes.
I'm just wondering, when these collaborations complicate what happens with the intellectual property?
I don't know. Study groups have always said, IP, no IP. You have to come and be prepared to talk about it in public, and that's the only way you can do it. After that, you perhaps have to negotiate. Do you ever have experience?
I'd say the same, that the study group is an open forum and it needs to be within
important to have thought about this because it will come up. There will always be companies who are very frightened about intellectual property rights, and in some sense it's a good sign because it's because they are bringing a problem that was very sensitive and very new to them. So I can certainly understand how it comes up, but certainly in Denmark we've also always been able to avoid this issue. If worst comes to worst, it is possible to reformulate a problem so that only the essential mathematics remains, and it really, as it stands, contains nothing that the company is really worried about, but they can still use the solution. So that's a well-tried path around IP issues.
Please note there's a microphone on the
other things of making companies, provide them a solution, they use it, and they're making money out of it. I mean, they make their product better. They make their product more competitive compared to other products. How is this concept actually protect? How does this protect you from using your solution to other non-collaborating industries as well? This is something that someone else find free somewhere? Or is it up to the industry that uses the solution on how to protect them?
I'm not quite sure. Can you formulate the more precise question? You mean we should get the money for it, or some money?
Yeah.
Yes.
That's what I'm asking.
Well, companies have to pay a fee to participate in the first group. So if there's a placement fee, really.
So yes, we had this question about the pricing of the problems. Actually, in the UK right now, they pay $7,500 to come and get the solution from 1 week.
Or maybe not get a solution.
And maybe not get a solution.
There is no promise.
We are starting only with 500 for small and medium sizes. So it's really a symbolic amount to ensure commitment. And people are set up an account here for a week. But okay, it's a valid question what happens afterwards. So as Joanna said before, we have other mechanisms after the first week to ensure the long-term collaborations, if it's needed, there is IP that has been developed to secure it under a contract. So this consultancy agreement is also the universities here started discussing, etc. Then it's one method that we can secure the forward after the 1 week. But 1 week is an open innovation process. According to the payment they do different in each country at the moment, but it's very small in Cyprus.
If your problem arises after the study group, is there a way to issue somehow? Or should a company wait for the next cycle?
So that's a whole challenge for Cyprus now, that after this week we keep the momentum still at it. And we have an ongoing year-round mechanism to discuss problems and solve them. It doesn't have to be during the study. The study group is a catalyst for this longer-term to happen and for new problems to generate arise in collaboration with and discussions with the company. So ideally, there should be a center, as I mentioned also in my talk, something like a Smith Institute perhaps in the UK, that there are commercial research associates in Bath. These are people that are between academia and industry. They can talk to both communities and they can bridge the gap between the two. They are translators essentially. So these people somehow we need to create this mechanism in Cyprus and have these people in Bath they have a PhD also in science. So they are very equipped when they go to the company to actually at live provide some preliminary ideas, etc., and convince the company that they can go further with the problem. I think do I say this correctly about the commercial research associates? So we need something similar. So we have to bring more people in the room, perhaps how this happens, to keep the momentum going.
But a smaller thing you could do would be just to have a workshop.
But we're having that already. Actually, we're having one-day workshop as a follow-up after the reports have been written. But again, we need to do many one-day ones perhaps, so follow-up meetings.
Sometimes there's a way to do a regular workshop for specific problems within universities where you would have to call in the right people.
Yeah, and in Denmark, we are experimenting with a concept called the rapid response force. This is maybe for the situation you are describing, that in between the annual study group, you suddenly are speaking to a company who really has an excellent problem that you think is soluble with a couple of days' work and the right people, and the company would really love to not have to wait 6 months or 7 months for a study group. Then we have tried a couple of times to assemble people and have them clear 2 days in their calendar and do express work on this particular problem. It can be done. It is not trivial to do in the middle of the semester for academics.
In my mind, this whole conference or this whole process is extremely valuable, and I would expect that coming from the industry side, that there are probably hundreds, or there should have been hundreds, or maybe thousands of companies lining up, trying to participate in those events and get answers, because you cannot assemble in your own company, let's say a research group, which is going to have all this brain power. So is this how it is in reality? This is happening in Cyprus now, but is this how it's in reality, and why do you think it's not?
Well, why aren't the industry queuing up, you say? I don't think they're totally convinced. They're very worried about their own time, usually. One of the things that's hardest to persuade someone, to take 3 or 4 days off to come and spend time is thought to be worth a vast amount of money to the industry.
But like the previous speaker said before the previous question, someone who's working in an industry or owns a company and needs to solve a problem that can probably make thousands or hundreds of thousands of income and improve their product. So this...
Well, it may not be quite as simple as that in that. I mean, one problem, it's not always that one, it's often an exploratory thing that one could talk about more than that for 2 or 3 days.
It's not often that it's recognized from its outset as a mathematical problem. So it takes some insight from the point of view of the company to realize that this issue is something that they could actually throw in front of mathematicians and get something interesting back. But the more research and development focused the company is, the better. because they know, then they have a better chance of knowing that if they solve this mathematical key issue, then or just and the insight that comes from mathematical modeling, then they will be better off.
I think it's fair to say that there are a few companies who have tried this mechanism and then come back each year on a regular basis. But can I turn the question back to you and say, well, how can we better reach you using your colleagues?
Well, I'll think about it.
Good. That's a good approach.
Okay, so maybe we can continue the discussion next door. I would like to thank